We're carrying on with this worksheet. So if you look at this question, you have a recyclable box for cold food. So you've got layers on the lid and layers here on the box walls or container walls. Yeah, right. The layers mean trapped air. Trapped air does not move. That means no convection. Right, what else would there be? Air is a poor conductor of heat, of thermal energy, conductor of heat or thermal energy. Right, okay. So you also notice that it's a thick wall, so that means there's less heat loss through conduction. Again, it's a thick lid. So you've got slower conduction, right? Okay. The cold food and ice packs are placed in here, in there, right? Give a reason why the net transfer of energy. So give a reason why there is a net transfer energy from outside of the box to inside of the box during transportation in a hot country. Right. When you have a temperature difference, so just say that's your box. But if this is hot and this is cold, you're gonna get heat being lost. If you've got cold and you've got hot, in this case, you're gonna get heat penetrating. And why is that in both cases? Because there is a temperature difference. This system wants to reach something called equilibrium, where temperature here is the same as the temperature here. Okay, so because the temperature inside, let's put it the other way, it's easier to say it the other way. The temperature outside the box is greater than the temperature inside the box. There you go. Explain how the box is designed to reduce energy transfer by conduction. Right. So we can, right, what I'm going to do is get rid of all that if I can. There you go, it's even better. I'm going to write it here. Right, the cardboard box is a poor conductor of heat Come on, a bit. Poor conductor of heat. It's a poor conductor of heat, so that's what reduces the conduction, right? Okay. Air trapped, because you've not got much movement of air. Air trapped inside the walls or the layers are poor conductors of heat. Because the particles are far apart, right? It's because they're far apart, they can't pass on the thermal energy, right? And you have thick walls, so the according to this, so the conduction is slower. You have a lower no, we'll leave it at that. I'm thinking of biology now. We'll leave that. So conduction is slow. So there's a few things. What are they? Cardboard as a material is a poor conductor of heat, so there's less conduction. Trapped air is a poor conductor of heat. Why? Because the particles are far apart. In terms of, what did they say in terms of, where are we? By conduction, right? So the particles are far apart. They can't transfer energy to each other. And the thick walls will make conduction, will slow down conduction. Right, okay, let's move on. Explain how the box can reduce convection. Right, so what we can do is we can say right, because the air particles are trapped, they can't move around to transfer energy via convection, can't move around. Also, the lid will reduce thermal energy loss. The lid will stop thermal energy loss by reducing or stopping, reducing convection currents. So what they're saying is, look, you've got a box. If you have not got a lid, what will happen is you'll get convection currents, and they'll take so the particles, the warmer particles will rise and start forming a convection current, right? And eventually what will happen is the temperature here all will warm up, because this thermal energy is transferred to the particles. So let me get this right. So this thermal energy will get transferred to these particles. These particles will then convect away. Yeah, so you've lost thermal energy here. These particles have gained it and then they've taken it away. Now if you've got a lid here, you've stopped these convection currents up here, so they'll just stay in here. So it'll stay cooler for longer. It will heat up less quickly. I hope that makes sense. Right. Students suggest that painting the inner surface is a different color will help reduce the rate of energy transfer. Explain which color. Right, okay. Remember what we said about white surfaces and black surfaces. So what they should paint the surface white or silver. You can use any one of those two, because so these are the 2 points, because the white stroke silver colors are poor, in this case, emitters of infrared radiation. So what have we said? The color white or silver. Why? Because they are poor emitters, right? And poor absorbers, so they leave the energy in. Right, on the other hand, so remember, so this is just something additional. This is nothing to do with that. So just remember, black surfaces are good absorbers of infrared radiation. Infrared radiation. Just remember that. Right. Okay, let's try question 6, or in this case, question 10. Right, so you've got a bar here, and it's painted white, black, white, black, and so on. So whenever you see that in this sort of question, think of black equals good absorber of infrared radiation. There you go. The bar of the hurdle is made of wood and is painted black and white. The temperature of the hurdle increases when the sun shines on it. Explain which part of the bar reaches the highest temperature. Okay. So what we can do is, so this part here is the black part of the bar reaches a higher temp because black is a Black is a good absorber of infrared radiation. And in this case, where's the infrared radiation? From the sun. The 2 marks come from this, from the sun, and black is a good absorber of infrared radiation. Okay, the air near the bar receives energy by heating. Explain how convection current is formed. Right, again, this is a standard answer, so learn this. Right. The temperature increases, the temperature of the air increases because of the sun, yeah? Because of the sun. Right, so what happens is, so the particles gain kinetic energy and move further apart. So the air becomes less dense. Now, less dense air rises and is replaced by cooler air. Right. As the air rises, it cools and particles, now the opposite happens, particles come closer together. And it becomes more dense. So what happens when it becomes more dense? The cooler, more dense air then falls. This process repeats. So what's happening is this, look. You've got air here. The sun heats it up. These particles move further apart. They become less dense. So this here, let's try it another way. This here then starts rising because it's less dense, right? So you've got, this is slightly warmer, and then you've got more cool air coming in from here, so they're closer together, so that's more dense. Now as this rises, it becomes what? It loses energy, it loses kinetic energy, so the particles become closer together, the density increases, so then it starts falling down. In the meantime, this is heated up, it moves up. In the meantime, this moves up. All that's happening is you get this convection current. It's like a cycle. Right, okay. Right, we'll call it quits there. So what did we learn? So if you look at this question, just or we do it on the next sort of setup. The black color is a good absorber of infrared radiation, right, and it's a good emitter. On the other hand, white is a poor absorber of infrared radiation. What else do you get? Right, this cat here has got fur. Fur is a poor conductor of heat. Fur also traps air. Trapped air. Well, air is a poor conductor of heat. Trapped air is a poor conductor. Trapped air also stops what? Convection currents. Right, we'll call it quits there.